Now I will show you a demo of the software which we have generated here. Once it's been installed on your computer, if you opt for it, you have this type of an icon. When you run it, it will open a page on your Chrome. So this will show that something is happening. It's trying to run the software. And you will see the modules which you don't have to touch, just for information. This will be a log, whatever is happening. It will automatically go here. It's just for troubleshooting purposes. It has four sections. First one is to select the DLU file, which it will convert into a CSV file, which you can even see, and it will show you the frames, subframes, and everything. So we will start from here. Uh, we will browse. It will open a menu like your Windows menu, and you will just select the file which you have downloaded from your FDR, and it's applicable only for .dlu files, which are Honeywell recorders. This is the words per subframe which we have described before. It's 256 because it's a 320 data. Scan DLU for frames. It will scan it and it will search for the sync words. And once it finds the sync word for all four subframes, it will take it as a one full valid frame. So it searched for the full file. It contains around 300 billion bits. It's 23,888 valid frames it found, and it's 97.58% good bits. Why it is 97%? Because you know that the frame consists of 4 second period. Whenever there is a power on off, switch on the FDR, it takes around 4 seconds to synchronize, minimum 4 seconds. So it's always more than 4 seconds, like 5 seconds, 6 seconds to synchronize, and then start sending the. That is why we have some bad bits inside every time. So it's 97.5. It's a perfect. So you can even extract selected information for 23,888. So you will press anything. You will see preview of it, or you can download a CSV. It's better to download a CSV so that you don't have to do repeat this step every time. So it's now converting into that whole 300 million bits into an Excel CSV file. Once it converts, it takes around 1 minute. You will have the option. So you can preview here as well. So if you have pressed this one, you will see a preview of the, the data here. You can see it on the frame look. So you can see word number one, word number two, word number three, and it is one subframe information called this is a raw data. So you will see for number one is always 583. For subframe one, for subframe two is 1464. For subframe three is 2631, 3512, and it will repeat. You will see. And rest of the data is almost changing, but you don't know what it is. It's a raw data. So you have the option of downloading it as well. So it will take around a minute, and you can download now extracted CSV, which contains all the parameters, and then you can save it somewhere. For example, I make a new file, new folder here, and then put the FDR data. You can select any word, any name as per your convenience, like for any aircraft registration number with date, and save it. Now there are two options here. Once you have the data downloaded, you can use the same CSV file or upload another raw data, like whatever we have saved the raw data in the CSV, you can select from there as well. But in this case, already we have extracted data, so we will use the same upload parameter library. So it's already defined. I have selected the 350, 320 parameter library, and this is the file. So it's a file generated by the FDR software of A320 for 330. It's available on the Airbus Online, and you can download it. Just it asks for some parameters of your engine type and the FDIMU software type, and it will download all this. And you have to make some changes in it, and which I can make and I have made, and then it's much easier to see every parameter, and then you can even amend it if there is any issue, and you can verify it. It's much easier to use. And then once you loaded it, it says 1581 rows selected. So you can see the parameters here. Now it's loaded into the software very quickly, and it's been loaded here. And now you have different type of these sheets which you have seen. So you select all, and if I want to check the role, I will just put role and then enter and drop down the roll angle, roll attitude. I have selected two of the parameters. And then I will also want to see the squat. Squat means but when the aircraft is on ground or not. So I will just select the squat as well. I will select N1, N2 as well. N1 actual, N1 actual engine 2. So move it and you will see all the parameters which you have selected. You have the option to select all parameters which are quite long. It will take a long time to download. So I have just selected few for a demo purpose. You can download this selected selection and save it in a location so that you can use it afterwards in future. Or you can browse. If you have already downloaded, you can browse it and see the different parameter selections I have already done. So if I have chosen mandatory, I can choose and then it will be available here. But I have already taken few of them. So either you want to take the full frames of data which you have taken, and then convert. So it took around 30 seconds to 35 seconds for see 7 parameters for 23,888 frames. And you can see it's one frame is 4 seconds. So 4 multiplied by 23,800. So you have around 95,552 rows for 9 parameters. And if you want to preview, you can preview from here. So it will show you the first. So here you can preview. So roll angle is coming, roll attitude is coming, compress means the aircraft is on the ground. If you move forward, it's only few 200 rows. So just for sample. It's another screen where you can see the live conversion. It's only for troubleshooting purpose. For if you have some doubt on the conversion factor, you can see the live value. For example, you will see for roll angle, word number 14, raw value is 4092 for frame number 67. So if you open your raw file and see the frame number 13, you will see the raw value of 4092 for 14 and subframe number 1234. So you can pause as well, can pause and see exact subframe when verify from your CHV which we have downloaded in this step. Here we can verify whether the frame number 24 contains raw value of 4092 for word number 14 and subframe number 4. And after conversion, after masking everything, the final value is 0.35. So you can see and actually multiply with 1023 and then see the number of bits required and see the signed bit and you can see the value. So it's only a converter. Here, you can see the graph of it. It's very flexible graph. You can see, you can move here and see the values for each point as well. So from here you can see it contains, the whole data contains one, two, three, four, five, 6 flights in it total in the 25 hours. Uh, if you open, you can see this graph is very flexible. I have not seen it in Honeywell or L3. If you can select any of the area and it will zoom it because it's working on Python's Codify library, which is very powerful. So you can zoom it and see everything here. See, every point is showing you the values of roll, landing gear part, not compressed. So it's in the flight and the roll angle is, you can see. So aircraft and up just flying its roll towards one side, the left side, or then move forward. So you can go back. You have the option that you can select parameters which you have selected, out of which you have selected here. Only out of 7, I can select any of the parameter for plotting it here. So if I have selected all the parameters, it will take a long time. For example, if I select, if I reset the selection, reset selections, and then ask for the major parameters, like there are around 61 parameters I have selected as major parameters. I have already created one CSV, and you just do the conversion. Well, press the button, and once the button is pressed, it will take some time based on the number of parameters selected and number of rows selected, number of frames you have selected. So it takes some time. Once it's converted, you have the option of looking into the CSV file you can download, and you can see the live data, and you can download the downloaded CSV file. Once you press, a directory will open. A window opens, and it will ask for the directory where you want to save the file, and you can even put the name, whatever name uh, you want to save for that file. Once you will open this file, it will open in a CSV format. You can convert it into a table for ease of use, and then adjust the column widths accordingly as per your requirement so that you can easily see the different parameters, because it contains 95,000 rows and around 70 columns. So it will be easier for you. So you can free some of the columns. You can adjust the height, the size of the cell so that you can easily, it's up to you. And then you can easily move around and see different parameters. You can mark them with colors. For example, if the aircraft is in flight, you can mark all those cells as blue so that you can easily scroll around and see what is happening. It will ease your analysis. Normally, if you send it to Boeing and Airbus, they will send you in a file with your FDRPL plus your CSV file. So every vendor used to send the the format is the same, CSV, because it's the only format which can easily be exported in a proper small size and easy to read as well, analyze as well. If they send it in the PDF, it's not possible to review it, or it's very big, difficult. Now, once the conversion is done, you can select any of the parameter to be plotted as in a graph. Like I'm selecting now landing gear squad switch along with whatever you write. If I say landing gear squad switches are there, all three are there selected, so it will show you a graph. As the file size is quite big, it's around 37 MB. So it takes lifetime to plot the parameters. So you have an interactive type of plot where you can see all the flights where the spot switch goes from ground to compressed to not compressed. So this graph shows around 1, 2, 3, 4, 5, 6 flights in it, and you can even check the frame indexes from here. And once you note down these frame indexes, you can select the frame index uh, from for that particular flight and select and then convert. It will reduce the memory usage and speed up your process. Once you know which flight is required, you can easily do it. And once you have the file available with you, you can play around with it. So it's quick and very fast. Even as I have the experience, if I provide the service, I can give you the highlighted parts of the Excel where I can say these are the parameters which are exceeded. In my previous company, their regulatory body has mandated for each airline to do an annual reasonability check on every tail number once in a year, so that you confirm that the mandatory parameters are recorded correctly. So this is the brief introduction of the software. If anyone needs more explanation or anything, I can provide. But it's very simple, easy to use, flexible, and you get all the features which are there available in big softwares of very high cost value. And you can play around with it with ease. It's very simple. So any other further question or queries, I'm available and I can explain whatever is there. And especially it's a locally designed software, we can make changes in it as well for ease of use as well. So thank you very much for your time, and we will I'm open to discuss anything further. Thank you very much.